Hello guys, already we have came to the end in analytical chemistry. Maybe this is the last video of analytical chemistry where we discussed different thermoanalytical technique. This thermoanalytical technique contains what are the parts? Analytical technique. Okay. This thermoanalytical technique contains TGA, DTA and DS. This thermal analysis is divided into these three common parts. Okay, thermogravimetric analysis, DTA and DSC. So let's start with thermogravimetric analysis, that is TGA. What is TGA and why it is done? Actually, TGA is a thermogravimetric analysis which is done to know the heat sensitivity or the heat stability of any material or sample that you want to use. Okay, so here what is happening? Here one sample is taken and it was heated. During the heating, it loses some weight, and when it loses some weight, then it is thermally unstable. At up to what temperature it remains its stability, and up to what temperature it does not show any decomposition, that's called the thermal stability of that compound. And from this analysis we can also determine what are the compounds are removed from the system or decomposed during the heating. So let's go through the principle of thermogravimetric analysis. In thermogravimetric analysis, the sample is heated in a given environment like N2, carbon dioxide, helium, argon at controlled rate. This is important, at control rate. So in this atmosphere the sample was heated, and in different atmosphere, in carbon dioxide atmosphere or in aerial condition, in different atmosphere, the result, that is the graph which we get from the TGA, that is called TGA graph or TGA curve, this will may be different in different condition. So how it is happening? The heat which is given to a sample is given in a control rate, that is it is has a it has a like this, it has 10 degree per minute, 10 degree centigrade per minute, that is in every minute we increasing 10 degree centigrade. Okay, so when we using this type of analysis, so this will give us more efficient idea of thermogravimetric analysis. Here we are plotting the weight change against the temperature. Okay, we have already tell that here we are taking the weight and here taking the temperature, then a graph is come, this type of graph. So at particular temperature, what is the weight of the sample is measured here, is called the thermogravimetric curve or thermogram. This is the basic principle of TGA. Okay, that is the weight change is account against the temperature that we increased in control rate. Okay, this is a quantitative and qualitative analysis. What is quantitative and qualitative analysis? What is quantitative and qualitative analysis? This qualitative analysis, here from this graph we can determine what are the compound present, and we are determined is quantitatively also, that's how much the compound is present. How can we determine the percentage of decomposition? Okay, percentage of decomposition. From the percentage of decomposition we can analyze how much compound is decomposed and decomposition. Composition. Okay, so these are the two things. One another thing, only solid substance can be analyzed by this method. Okay, so only solid sample can be analyzed in TGA. No liquid or gaseous sample is analyzed. But in nowadays, the techniques and the instrument are more efficient. So some liquid sample or nearly gel type sample can also be determined using this thermogravimetric analysis. Okay. So when only solid sample that was analyzed in this method, is the solid sample how the solid sample come? Actually, we have reactant molecule, and when we have reactant molecule, this reactant molecule may form product, and this during the formation of product may be some amount living as a gas. As something amount is living as a gas, then reactant, the mass of the reactant decreases during the reaction. If any reactant reacts with some gas, then the product which will form, that will increase in the mass of the compound, the mass of the reactant. So there is some reaction where the mass is lost, and there is some reaction where the mass is gained. So actually we can determine how the reaction will proceed also. So is it a gain of mass reaction, or is it a loss of mass reaction? So this measurement of change in sample mass with the temperature are made using thermobalance. So how it is measured? So we have measuring the mass during the temperature. So as it is a thermobalance as was there to measure the mass of the sample when the temperature is changing in a constant or controlled rate. Process occurring without change in mass, that is the melting point of the sample, cannot be determined by this TGA method. So anything, so what is happening in melting point? When any sample is melted, okay, any sample is melted, that means it has a solid sample and it become melts into a liquid sample. So when it melted, there is no change in weight, change in weight. So as there is no change in weight, we can't determine it using TGA curve. Only the sample is loose or gain some weight during the heating is determined using this TGA. Okay. Now let's take an example of AgNO3. Very simple example, and it will help us to know what is the thing happening here. So here we can see a TGA graph. Let's this is written as A, this is written as B, this is written as C, this is written